175 Fletcher-class destroyers were built during the Second World War, the largest production run of any American destroyer class. The first ship, USS Fletcher, was commissioned on 30 June 1942. Some of her sisters were still in service in the 1970s, rebuilt so thoroughly that almost nothing above the weather deck matched the ship that had been launched. The interesting question is not what made the Fletcher lethal. Any destroyer that carries 5 guns, 10 torpedo tubes, and a 37-knot plant can do damage on a given night. The interesting question is what made it adaptable, what quality in the original hull kept absorbing new radars, new guns, new sonars, anti-submarine weapons, and an entirely different mission, decade after decade, without the Navy ever needing to draw a new ship. The answer is visible the moment the hull is opened from bow to stern. The Fletcher was the first American destroyer designed without reference to treaty limits on displacement. That freedom brought not a larger weapon or a faster engine, but a margin room left over after every gun mount, torpedo bank, turbine casing, and magazine had been fitted in place. The hull was not empty, it was not generous. It was just large enough that the next edition, whatever it turned out to be, could find somewhere to go. The class table gives the dimensions: roughly 377 feet of length, 40 feet of beam, 2 shafts driven by geared turbines off high-pressure superheated boilers, 60,000 shaft horsepower, and a cruising radius of 6,500 nautical miles at 15 knots. Full load displacement ran a little over 3,000 tons. Those are numbers for a ship that had to do several things at once. A destroyer in the Pacific Fleet screened carriers and battleships, answered aircraft, watched for submarines, and still carried a weapon for surface attack against other destroyers and cruisers. The Fletcher kept 5 single 5-inch 38 dual-purpose mounts and 2 quintuple 21-inch torpedo banks aboard while accepting the 40mm and 20mm anti-aircraft guns the Pacific kept demanding. Previous treaty-limited classes had been forced to choose, trading torpedo tubes for guns or guns for speed. The Fletcher did not trade. It carried the full set and still had deck space and internal volume left over, not much, but enough. By the end of 1943, Fletcher-class destroyers carried the bulk of frontline destroyer duties in the Pacific. The first ships had arrived, while American destroyer tactics in the Solomons were being rewritten by failure, and by the time the tactics caught up with the hardware, the Fletchers were the ships doing the fighting. The 5-inch 38 was the primary American destroyer gun, and on a Fletcher it sat in 5 Mark 30 enclosed base ring mounts. Each mount was only the visible top of a vertical ammunition system that continued below the deck. Handling rooms and magazines supplied the working crews, with dredger hoists bringing shells and powder cartridges upward in stages. Rounds began in the lowest spaces and rose toward the gun through a chain of hands and machinery. Shell and cartridge were separate, and the mount itself did the last of the work. The base ring turned with the gun, while integral shell hoists and cartridge scuttles brought ammunition to the loaders in a consistent working position regardless of where the barrel was pointing. The crew did not have to pause while the gun returned to a fixed loading angle. On enclosed base ring mounts, the shell hoists also set time fuses on the way up, so each round arrived at the loaders already fused for the engagement. The separate fuse setting station that older open mounts required simply disappeared. The gun was hand-loaded and power-rammed, and the rammer is where the rate of fire lived. Ramming was power-worked on every mounting, either pneumatically or by a 5-horsepower electric motor driving hydraulics, and it could seat a round at any elevation. A gun crew tracking a diving aircraft with the barrel high could keep feeding the weapon without pause. What happened when the power failed was demonstrated at the Battle of the Eastern Solomons. 2 of Enterprise's 5-inch guns lost power, and their crews fell back on manual ramming. The rate of fire dropped by more than half. The same report credits the carrier's 5-inch battery with 3 dive bombers shot down for an expenditure of 97 rounds, the kind of economy the power rammer made possible. The cycle had a rhythm that was as much choreography as machinery, still gives the firing cycle as 2.7 seconds. A 55-pound shell leaving at 2,600 feet per second, reaching out to 18,200 yards at 45 degrees of elevation. Its Spent cases were thrown automatically out the back of the mounting at elevations up to about 40 degrees. Above that, the spademan deployed a cartridge case stop and pulled the hot casing clear by hand, and the hot case man carried it off the mount. Inside the thin enclosure, 1/8 of an inch of plate, enough for weather and splinters, but not for shellfire. Sustained fire was a team working in a space barely large enough for the work. The system was also durable in a way the Navy eventually measured. Off Okinawa, 5-inch ammunition was being expended fast enough to raise concern about barrel wear, and 2 Fletcher-class ships were ordered to shoot an offset accuracy trial. One of them, Richard P. Leary, had fired about 4,270 rounds per gun, her worn barrels still grouped within the gun's nominal accuracy specification. Amidships, the 2 quintuple torpedo banks carried the ship's heavier surface weapon. The class retained both mounts through the war, even as anti-aircraft additions accumulated on every available deck fitting. American destroyers did not carry torpedo reloads the way Japanese destroyers did, so the first salvo from those 10 tubes had to count. In the early Solomon's fighting, it often did not. The Mark 15 torpedo had technical faults, the Mark 6 magnetic exploder was unreliable, and the weapon tended to run below its set depth. American doctrine compounded the problem by keeping destroyers subordinate to cruiser gunfire rather than releasing them as independent torpedo platforms. Nimitz said on 15 February 1943 that in no night action had destroyers used their major offensive strength effectively. 5 days later, Rear Admiral Marlon Tisdale issued a tactical bulletin that began to change the terms. Japanese ships of destroyer size and above were to be treated as proper torpedo targets. Mark 15 speed settings were lowered to extend range. Torpedoes were set shallower. Nimitz permitted the magnetic exploders to be turned off in June 1943. Firing pin springs were replaced. By mid-July, the destroyer-launched torpedo was a largely corrected weapon. Meanwhile, the radar set above the bridge was rewriting the geometry of night combat. A Fletcher-class example, USS Nicholas, carried SC search radar on the foremast, SG surface search radar below it, and Mark 4 fire control radar on top of the Mark 37 director. SG gave range and bearing on a plan position display, a radar picture of the sea surface. Mark 4 helped the 5-inch crews engage targets at night and in poor visibility, connecting the gun system to a sensor that could see past darkness and weather. Radar still had limits. Close or fast-maneuvering targets could confuse it, and fire control radar could chase its own shell splashes instead of the ship being fired at. But the combination of corrected torpedoes, surface search radar, and fire control radar gave American destroyer commanders something they had not had at the start of the Solomon's campaign: the ability to find the enemy first, attack with torpedoes at range, and follow up with aimed gunfire before the enemy could reply. Everything aboard the Fletcher converged on the night of 25 November 1943. 5 American destroyers met 5 Japanese destroyers off Cape St. George in the last major surface action between American and Japanese destroyer forces. American radar picked up the Japanese formation at 22,000 yards. Captain Ali Burke closed the range. At 5,500 yards, 3 American destroyers launched 5 torpedoes each, then turned away at 30 knots to avoid a counterstrike. 3 Japanese destroyers were sunk. No American ship was damaged. That result was not the product of a single advantage. It was the convergence of every system the Fletcher hull carried. Radar found the enemy at long range and held the contact while Burke closed. Corrected torpedoes ran true at the set depth and detonated on contact. The turn away at 30 knots was possible because the 60,000 horsepower plant could push 3,000 tons of ship fast enough to open range before a counterstrike could arrive. And the 5-inch battery, the same vertical machine reaching from magazine to mount, the same power-rammed loading cycle, the same fire control radar linking the director to the guns, was ready to engage whatever survived the torpedoes. The 2 American destroyer victories in 1943 at Vela Gulf and Cape St. George both resulted from surprise torpedo attacks set up by radar. When surprise was lost, the Japanese won or drew. The balanced hull did not guarantee victory. What it guaranteed was that a competent commander had every tool aboard the same ship and enough margin to use them together. Return to the ship's profile one last time. 5 gun mounts, each supported by an ammunition system below deck. 2 torpedo banks amidships, 10 tubes loaded, no reloads. A steam plant produced 60,000 shaft horsepower on 2 shafts. A director and radar group above the bridge linked the sensors to the guns. Every system fitted into a hull just large enough to carry them all and still leave room. The war ended and the fleet drained. By 1950, only 5 Fletchers remained active, parked in the Naval Reserve. The Korean War brought roughly 100 of them back, and what returned did not stay a 1944 destroyer. 18 were rebuilt as escort ships with most of the gun battery, both torpedo banks, and every 40mm mount stripped out, replaced by a head-throwing anti-submarine weapons and homing torpedo tubes. 40 more traded their torpedo banks and light anti-aircraft guns for new 3-inch mounts, Hedgehog launchers forward of the bridge, a tripod mast carrying new search radars, a new combat information center, and new sonar. The same hull accepted all of it. The margin that had let a 1944 crew fight 5 guns and 10 torpedo tubes at once was what let the 1950s Navy replace the topside arrangement and rebuild the ship for Cold War service. What lasted was not a perfect ship. What lasted was a margin that kept finding work.